Good morning, everyone. Welcome back. Thank you for joining us. We're glad you're here. I'm Steve.
And I'm Scott.
Together, we're Backyard Musings, Science and Technology Channel.
Yep. And we're grateful that you're here. And we are definitely talking about a science topic today. This is, I got a few geothermal stories I could tell earlier in my plumbing supply career. So, but we won't. We'll just get into it, talk about this story. These guys are the experts.
Flatulence?
No, I'm talking about a guy that developed a geothermal heating and air conditioning system for homes using 12-inch diameter pipe. And he would either drill it in the ground, or if your home happened to be near water, which there are a couple of lake communities here, Silver Lakes, Spring Valley Lake, and the lake community would let you do it. He would use the water from the lake, but he would drill down these tubes, and depending on the size of your house, you could have either 3 or 4 or 6 tubes going vertically into the ground. And then, at a certain level in the ground, the temperature doesn't change, right? It's like in a basement. And he would use that with a heat pump. He would draw air, heat in the winter, cool in the summer, and they work great.
How would it be cool in the summer if it's hotter underground?
Oh, it wasn't hotter. It's a constant temperature at a certain level. So I don't remember how far he had to go. Sometimes he'd have to drill, it was almost like drilling caissons or for a leach field for a septic tank system.
These are deep geothermal. Let's get into it.
Yeah, and at first they were kind of costly, but after he got going, it worked out. I don't know how many of those things were still in use. This was probably back in the early 80s that he was doing that. But yeah, people bought into it. So, but then I think he got sick or passed away or something, or moved or whatever. And then the guy that was his partner didn't want to stick with it. So, but yeah, it was a cool idea. I remember going home and telling my dad about it, and he was all fired up about it. It was pretty cool. So, anyway, here we go.
Geothermal energy has been around since Earth's creation and exists almost everywhere. Yet harnessing its full potential has proven difficult since viable sources are often difficult to find. Quote, the U.S. has a lot of it, and most of it is in the U.S. is untapped. It's a tremendous sort of resource base that's waiting for us to go after it. Zanskar is the company, Joel Edwards said. Geothermal energy is generated by the Earth's formation and ongoing radioactive decay. It is stored beneath the surface and accessed by drilling thousands of feet underground. Would you like to know more?
Yeah. Geothermal energy makes its way to the Earth's surface through volcanoes, hot springs, and geysers. It has been it has been otherwise difficult to detect above ground until now. Quote, we have made more discoveries in 3 years than the industry found in 30. This is according to Edwards. Zanskar, a geothermal company, is making the search for hot sources more accurate. The company has built artificial intelligence models, there we go, that are able to detect geothermal resources and target them with deeper drilling. Okay.
Quote, we have found dozens of sites, and they were either overlooked or they were just in areas where nobody had ever looked, Edwards said. Once we find these systems, we're having much more success drilling into them because those models are better at sort of simulating all the possible orientations of a geothermal system.
Historically, geothermal production has carried risks of drilling into inefficient wells. These are safety risks in geothermal production and environmental concerns over air and water pollution. I wonder why there are safety risks. Is that because they're creating a cavity that could maybe create a sinkhole, or I don't know.
Or lava coming up.
Yeah. The uncertainty has caused delays in permitting and operational challenges. Quote, what happens is you drill moderately productive wells, marginal wells, or you drill unproductive wells. All of those failures, they get rolled up into the total cost of a project, and that drives the cost of the project up, Edwards says. That makes sense.
Yeah. The best geothermal resources in the U.S. are located in the West, where much of the land is owned by the federal government. The Interior Department has implemented emergency permitting procedures to accelerate reviews of geothermal projects as part of President Trump's energy agenda.
Quote, it takes typically like 3 to 7 years to get these projects permitted. Luckily, in the last few years, there's been an urgency to cut red tape, and that's according to Edwards again. And going on with the quote, and that's already having a material benefit for those of these or some of these earlier stage projects.
Continuing his quote, he says, what we have to do is work with our federal, state, and local partners to drive those solutions that you're talking about. We cannot think of this technology as it's happening to us. We have to partner and utilize it just like everyone else. Exelon CEO Calvin Butler said, that's another competitor. AI should help us all become more efficient at what we do and get better at.
The geothermal industry has similar challenges and risks as oil and gas. Society of Petroleum Engineers began promoting the use of AI as early as 2009. It has helped improve exploration, drilling, and development. Studies show some of the same techniques could help geothermal production.
Quote, it sort of feels like where oil and gas was maybe 100 plus years ago, Edwards said. We didn't know how much of it was out there and so forth. That's what geothermal feels like.
Quote, like it just feels like we're barely explored for it. We've got a little bit of it going. We've got a little bit of it going right now. We kind of understand it, but now the market is out there, and the market's like, we want this stuff. Really, this guy's an engineer.
Totally,
yeah.
Dude.
Yeah, totally. As artificial intelligence helps track new sources, there are still concerns over its immediate effect on the electric grid.
Quote, it's a challenge, but it's a huge opportunity, and that is what we're most excited about, the opportunity to be part of this journey, this next wave of the energy transformation, because we can't just look at it as a challenge and say, we don't know what to do, Butler said. We're partnering with our technology partners and saying, what can we do to make this a win-win for everyone?
Yeah.
All above approach, right?
I guess, but again, they talked about it in here, the government bureaucracy tying this stuff up instead of just letting them go with it. Give them a couple sections of land that we're not doing anything with. Let them go out there and see what they can do. And if it doesn't work out, then, make them responsible to put it back the way it was. Kind of like this solar plant that we got out here in Prim, Nevada, south of Prim, Nevada. What are they going to do? Is somebody going to come in there and tear that all apart? Probably not. It's probably just going to become a ghost town of a solar plant. And I don't know. I'd rather see them do something like this, where they're using resources from the ground. So anyway, my take. Thanks for watching.
Let's see where it goes. Appreciate you. We'll see you in the afternoon.
Yep. We'll see you this afternoon. Take care.